If a process is out of control, then special causes of variation exist in the control chart. These special causes must be found and eliminated in order to achieve an in-control process. There are a number of guidelines we can use for assessing the presence of special cause variation. Within programs like Minitab, these guidelines are programmed in. We have the ability to raise or lower the bar on any of these guidelines. Minitab does set a default. Adjustments to these criteria will be based on our risk attitude, available resources, and dedication to the elimination of special causes. A run is a series of points on the same side of the median. Runs can be one or many points. Too few or too many runs are important signals of special causes, suggesting that something has changed in the process. Recognize that the number of runs in a stable process depends on the number of data points. One thing to be careful with regarding these rules is that you may not want to react too quickly. Several factors need to be considered. First, are consequences high if we do not react to a potential unstable system using the 8 rules? Second, can we potentially make a process unstable if we react too quickly to the control chart, when in reality the process is not out of control? In other words, do not fix it if it is not broken. And finally, some suggest using only 1 to 3 of the rules for stability testing of the process. Using only a portion of the rules will minimize the potential instability caused by tampering with the stable system. However, you could be potentially reacting to false alarms. Beginning with this slide and the 7 slides that follow, we will showcase 8 guidelines for special causes and variable charts. Our first indicator of a special cause is when we have 1 point outside the plus or minus 3 standard deviation interval from the center line. We term these occurrences as outliers, or measurements very different from the others. Our second indicator of a special cause is when we have 2 points of any group of 3 points outside the plus or minus 2 standard deviation interval from the center line, but on the same side of the center line. If we see 2 of 3 points in a row outside the plus or minus 2 sigma level on the same side, we may expect an unnatural large fluctuation or the onset of a divergent process. When we have 4 of any group of 5 points outside the plus or minus 1 standard deviation interval from the center line and on the same side, then this would also be an indicator of a special cause. We call this bunching or clustering. Such behavior is most common in X-bar R charts or P charts. Another signal of special cause variation is 9 points in a row on the same side of the center line. We call this a sudden shift. If we see 9 points on the same side of the center line, this indicates that the central tendency of the process is drifting. We can confirm this by looking at the R chart where applicable. If we see an increase, then the process is unstable. When we have 6 or more points continuously increasing or decreasing, it is deemed a trend. Trends are another type of special cause. A cycle is defined as 8 or more points in a row on the same side of the central line. Cycles are also considered special causes. Another indicator of special cause would be 15 points in a row within 1 standard deviation of the center line on either side. 15 points within 1 sigma of the center line are indications of stratification. Look at the R chart to best see this behavior. Finally, if we have 14 or more points in a row alternating up and down, this would also be indicative of a special cause or seesaw effect. 14 points alternating up and down is indicative of a process capability that is diverging. These 14 points are no doubt the beginning of the end regarding process stability. Attribute chart guidelines for special causes are fewer, yet shared with some of the guidelines mentioned earlier. They include any point outside the plus or minus 3 standard deviation from the center line, 9 points in a row on the same side of the center line, somewhat similar to a shift in the process, 6 or more points continuously increasing or decreasing, and finally, 14 or more points in a row alternating up or down.